Section 3.5 deals with exponential and logarithmic equation applications. So the first thing that we very commonly use these for is when we're doing compound interest formulas. So there are two versions of the compound interest formula that you need to be aware of. The first is if we're going to compound n times a year. So A is the amount of money at some time t, P is the principal or initial amount invested, R is the interest rate, and you need to make sure in the interest rate that you know it is in decimal form when we plug it into the equation. T is the time in years, so if you're given a unit of time outside of years, you need to convert. And N is the number of times per year. So on this guy, one thing we need to make sure that we're aware of is a lot of times we're not just going to say compounded 5 times a year, compounded 3 times a year. We might describe the way we compound in using vocabulary words like semi-annually, that means twice a year. Quarterly, right, means 4 times a year. Monthly means 12 times a year. So be prepared, right, that N may not always be explicitly stated. The compound interest formula when compounded continuously is A equals P times E to the RT. And so these are actually versions of the same formula, and what we mean by compounded continuously is that the value of N has gotten so big that the base of this equation is not really changing. So E to the R is actually this part of the formula up here, because notice there's a P, the principal, and we're raising everything to the T. So these are equivalent as N gets big. So if you were to keep playing around with this guy and just keep plugging in bigger and bigger and bigger values of N, you would see that as the value of N got really big, and really it doesn't even have to get that big, really once it gets past about 365, maybe 400, you start to notice that it's just the same value as E to the R. So these aren't two distinct formulas. This formula turns into this formula as we compound it more and more and more. So let's look at an example. We are going to invest money in a savings account that compounds interest quarterly. So because it says quarterly, quarterly is 4 times a year, so we know we're using the first version of the formula. If you want the money to double after 12 years, what is the minimum interest rate you must find? And this says round your answer to 4 decimal places. So our N is going to be 4 because we're compounding quarterly. We're told that it's going to be 12 years later where we want it to double in value. And notice we weren't given the amount of money we invested, but we're told that if we want the money to double, well, then that just means it's going to be 2 times whatever the principal amount was. So the equation that we want to use is A equals P times 1 plus R over N raised to the N times T. So now let's plug in what we have. So RA is 2 times P. We just leave P alone. The rate is what we're looking for, but N is 4. And so 4 times T, 4 times 12, is 48. So we want to solve this equation for R. So the first thing that I see is that P cancels from both sides. Then if we use our properties of exponents, well, if I need to get the R out from inside this expression, I could take natural log of both sides and move the R out, but then the R would be trapped inside of a log, and that doesn't help me. So we can use the idea that if we raise this to a power, right, I would multiply those 2 powers together. And the whole idea here is to turn this into a 1 so I can deal with what's inside here. So if I raise each side to the 1 over 1 or 1 over 48, then look what happens on the right side. 1 plus R over 4 raised to the 48. When I raise it to the 1 over 48, well, now 48 times 1 over 48 just leaves you with 1 plus r over 4. So essentially what we've done, if this were a square root, we would take, or if this were an expression squared, we would take the square root. So essentially what we just did here is we took the 48th root of both sides. That's another way of looking at this. So now I just want to solve this for r. So I have a 1 here, so I can subtract 1 from both sides. That leaves me with r over 4. And then I can multiply the whole thing by r. So notice this is a rare gem of a problem where we actually ask you to round. So a point about when you're rounding in decimal places, do not do any intermediary calculations. We expect you to solve the problem algebraically, enter the final expression, and then round, because otherwise you're not going to get the correct answer. So I want to show you how to properly enter this into your calculator. So you're using your TI-30 calculators that you're allowed to have, right? I'm using a TI, but I'm going to type everything the way you would have to type it on there. I just like this particular camera because our calculator, it shows up nice on camera. But the syntax properly to do this is you have 4, open your parentheses, 2, notice here that you have a fractional exponent. So you should have a caret button on your calculator. Then what you need to do is you need to open a set of parentheses, 1 divided by 48, and then close the parentheses. So what you've done is you've locked 1 over 48 into the exponent. If you do not put these parentheses, your calculator is going to read this as 2 to the 1 and then divide the result by 48, and that's not what we want. Then I'm going to subtract 1, and then I'm going to close the parentheses that I have here on my expression. So now when I hit enter, I get 0.0581. It does not specify in this problem, so I'm going to write out a bunch of decimal places. Oops, 0.0581813. So I'm going to round to 4 decimal places, but this problem did not specify the units of r. So we could leave the rate in decimal form, or they could ask us to convert to a percentage. So if we leave the rate in decimal form, and we just count to 4 decimal places, we can see we have 1, 2, 3, 4. The next digit is an 8, so we would round up. So if I kept this in decimal form, 1, 2, 3, 1, 2, 3, 4, oops. This should be a 2. However, if we wanted to go back to percentage form, the correct way to round would be to take your raw number, turn it into a percentage, and then round the percentage to 4 decimal places. So we turn this into a percent by multiplying times 100. So 5.81813. That's why I went out quite a few decimal places. And now if I go 1, 2, 3, 4 decimal places, right, we can see this is a 3, so we keep it. So this is 5.8181%. So these are both the rate, but you just want to make sure you clarify what the form of the rate should be.